Hello, Krishna, I'm audible. Please just confirm. Okay, let us wait for 5 minutes. Maybe a student will join. Hello, Kedar, I'm audible. Please just confirm me. Okay, okay. And slide is visible. Week number 8. Pipe flow in pipe. Okay, okay. Let us wait for 2 3 minutes more. Maybe another participant will join. Then we'll start the question answer session. Okay, let us start. The first question is, you can write your answer in the chat box. So the first question is from week 8, which is about the flow in pipes. So the first question, the average velocity V average for fully developed laminar pipe flow is, here V max equal to the maximum velocity. The V max is represent the maximum velocity. So what is the relation between your V average and V max? If water is flowing in a laminar, water is flowing in a pipe, the condition is laminar. You can also tell when the water will flow between two parallel plates, then what will be the relation between, this is the first one, this is the second one, what is the relation between V average and V max? So for first, what is the relation between, you can choose option A, B, C, D, and for 2 you need to give your answer in the chat box. So for question number 1, okay, you are telling the option A is correct, good. But let us see which option will be correct. But you can also give the answer of this question. Whatever I have drawn the figure, a flow parallel between two plates. The maximum velocity and average velocity relation. I'll wait 1-2 minutes, then after I will explain. Okay, the flow between two parallel plates, if you don't know, then I can tell you. So please try to give your answer, then I will tell you. Okay, the next week will be 9 week, week number 9, which is related to your, okay, we'll discuss later. So now I want to explain. The V max here, your V maximum, that is your velocity distribution will be like that. If laminar flow, it will be parabolic. After fully developed flow, what do you mean by fully developed? I will discuss here. So this is the maximum velocity. This is V max. If you will average this, like here is velocity 0, here velocity 0. If you want to make average, then this much, this much. Average means what? This type of velocity distribution. This is V average. So definitely your V max will be more than your average. So it will be 2 times of. There is a derivation for this, so I will not derive here. Average. Similarly for your plate, your V max is equal to 1.5 times of V average. Remember please. So now I want to discuss about the fully developed flow. What do you mean by fully developed flow? So let me discuss here. So let us suppose a pipe, one pipe is here and water is flowing in this direction. So initially, let us suppose water is entering with the uniform velocity throughout the cross section. So initially, due to the no slip condition, your velocity will be here 0 and then increase and increase, similar this like this here. Initially your velocity diagram not will be the parabolic. After moving, as your fluid travel in this direction, this is in the length direction along the length of the pipe, so your no slip condition or due to the viscosity, the effect of no slip condition, or you can say the wall condition or viscosity, this resistance propagates towards the center. From here resistance propagates towards the center. So after certain distance, because up to that much distance resistance propagate up to that much only, but as it move forward, the resistance travel that much, like that. Here similar type of, similarly in the rest part. So after certain time your resistance from this side and from this side will reach at the center from both sides. After that, here your velocity diagram will be like that. Up to that much is parabolic if laminar flow, and then after it is like that, not parabolic. Here also up to that much parabolic, then after straight, then after vertical here. But after this your velocity will be completely parabolic. After this your velocity diagram will not change. If any obstruction will come in the flow path, anyone want to tell something? Hello Krishna, you want to tell something? Okay. So here after that your velocity diagram will not change. So up to that much, this length is known as development length or fully development length. After that whatever the flow will move in the along the length direction, this flow is known as fully developed flow. Fully developed flow, and this is your partially developed. So remember please, for laminar flow, the relation actually fully developed length, if I write through the L, so what is the relation between, it may be the function of your Reynolds number or the diameter of the, so these things I will discuss later. For laminar, for turbulent, what is the relation between? But here I remember one thing, in case of open channel flow, if water is flowing like that, in a rectangular channel, open channel flow, so your fully developed length, that is length fully developed, it may be 40 to 60 times of your flow depth. 40 to 60 times of flow depth. Means if your flow depth is, let's suppose 20 centimeter, then developed length how much? This is a thumb rule, and after the experiment researchers have find out it may vary between the 40 to 60. So development length in open channel OCF, if I take the average, that is a 50 times of 20 centimeter, it means what? That is 100,000 centimeter means what? 1 meter. 1000 centimeter, yes, here, so 10 meter, it will be 10 meter. So development is like that in the open channel. For pipe flow, I will show you in the PPT I have. Okay, so here if you want to see the note point, in laminar flow, the velocity profile follows a parabolic distribution within the maximum velocity occurring at the center of pipe, whatever I was discussing here, gradually decreasing to zero at the pipe wall. Yes, definitely, because of the no slip condition, the average velocity is defined as the total volumetric flow rate divided by the cross-sectional area of profile. The average velocity means what? Average velocity is defined as the total volumetric flow, that is your discharge, divided by cross-sectional area of pipe. So this is the average. So hope you people got it what I was trying to tell you. Next question is question number 2. The Reynolds number Re is not a function of fluid velocity, fluid density, characteristics length, surface roughness, fluid viscosity. So you please try to give your answer. Question number 2. So Kedar is telling option C. Okay. Krishna, if you want to give your answer, you can write in the chat box. Okay, surface roughness. Okay. Yes, you can open your mic, you can tell, or otherwise you can write in chat box. Both option is available, no problem. Okay, so let me discuss. So here we are talking about the Reynolds number. Reynolds number is, if I write in the generalized form, yes, rho Vd by mu, okay, you are telling rho Vd by mu. Yes, if your flow in circular pipe, now I want to tell you, your pipe is rectangular. Your pipe is rectangular. Then what will be the value of D? If it is circular, then this formula is okay. But if your pipe is other than circular, you just think about it. Just for example, sake of your understanding, I am taking the rectangular one. So what will be the formula? If you want to try, then otherwise I will discuss how you will calculate. Okay, so let me discuss. So your Reynolds number is rho density of fluid into velocity, or you can say the average velocity, into characteristics length. I can write in the LCH, so it will be very clear to what you mean by LCH, the characteristics length. Now this is the dynamic viscosity of fluid. So this is the complete one. So actually your characteristics length, somewhere the notation may be different. Somewhere it will be defined by the capital D. But if I write here, your capital D is equal to what? 4 AC by perimeter. 4 AC by perimeter. So first of all, I want to give the answer of this question. So your Reynolds number depend on density, depend on your velocity, depend on your characteristics length, depend on your dynamic viscosity. So the remaining answer is surface roughness. Yes, surface roughness is a correct answer, because the question is Reynolds number is not the function of your surface roughness. So option D correct for this. Now let me discuss what I was trying to tell you. So actually now I want to calculate this D value for circular one. So if the diameter of the circular pipe is small d, so 4 into pi by 4 into d square divided by perimeter. Perimeter means what? Pi into d. If your cross section is circular, then we are talking about. But okay, so here you can see very easily your capital D is equal to D. Similarly, you can find out for your rectangular one. If your cross section is rectangular, then this will be your width W, this will be your height H. So you can very easily calculate D is equal to here, or LCH you can also write. I am writing D because in many textbook directly written capital D. So 4 AC means what? Cross sectional area. So W into H. Perimeter means what? Your W. 2W, because 2W, because this one, this much or this much, both will be in contact of fluid, and this much, this perimeter and this perimeter will be in the this periphery, and This one will be contact of the fluid. So this is 2H also. So now you can very easily write 2WH divided by W plus H. We take the common and will divide, so it will be 4 by 2 by 2. So this is your D value for your rectangular one. So remember please for your exam point of view and another exam also. So similarly for any type of cross section you can calculate the characteristics length. Now we'll move ahead on the next question. Here you can read. Okay, definition is there, but now I want to read for you. The transition from laminar to turbulent flow depend on the geometry, surface roughness, flow velocity, surface temperature, type of fluid, among other things. After exhaustive experiment of in the 1880s, Osborne Reynolds discovered the flow regime depends mainly on the ratio of inertial force to the viscous force in the fluid. Mainly depend on the these two things. There is a many things, but this is the mainly depending things, inertial force and the viscous force. That's why your Reynolds number is the ratio of what? Inertia force by viscous force. Okay, the ratio is called the Reynolds number, is flow expressed for inertial flow in circular pipe like this. Rho VL, L is the characteristics length, often the hydraulic diameter for pipe. Mu is the dynamic viscosity. Okay, everything you know already. So now moving ahead with the next question. Question number 3. In a fully developed laminar flow, hope you got it. What do you mean by laminar? A fully developed laminar flow you know already. Okay, I will discuss laminar flow for some student, maybe new student, maybe little bit confused with the laminar and turbulent, so I can discuss in this question. So in a fully developed laminar flow, the friction factor is the function of surface roughness, Reynolds number, A and B, none of them. Fully developed laminar flow. Here we are talking about laminar flow. Remember please. Okay. Okay, okay. So let me discuss. Oh no, you have the option. You are using mobile. Okay. If you are using mobile, you can. Oh, let me just check. You have the option. Let me just. I will tell you. Wait few minutes. Just wait because I am. Let me join through mobile. Then I'll. Okay. Okay, now you please. Okay, let me discuss. So, hope you people know about the Moody's diagram. So, I'll discuss later. But for this question, here we are talking about the flow. Your flow may be turbulent, generally, maybe laminar, or maybe turbulent. Transition, but very few for very few minutes or few times, we generally talking about in the fluid flow laminar and turbulent at BTech level. So in laminar flow or in turbulent flow, we need to calculate the friction factor for what? I'll discuss. Friction factor basically you're related to the head loss. 4 FL V square by 2 ZD. It is visible? Hello? Okay, you are telling. Okay. So this is F is of your friction factor. This friction factor is different for your laminar case, that is the formula, and for turbulent case it will be different. For turbulent case, this friction factor we calculate generally with the your Colebrook-White equation, and the Moody's just make a diagram using the Colebrook-White equation. So you can write the Moody's diagram. If you know the formula 1 by root f, something is equal to like that for your calculation of the friction factor in case of turbulent flow. But in case of laminar flow, you will calculate your friction factor using the 64 by Re only. This formula for calculating in case of laminar. So here your in case of laminar, your friction factor depend only on your Reynolds number. But when you will talk about the turbulent fully developed flow, it will be depend on, okay, I will discuss later. So for this question, question number 3, option B will be correct. Remember please. What is actually, I think, here is option is wrong. So remember please, but in explanation is right very clear. Okay, the friction factor is a function of Reynolds number only, independent of the roughness of the pipe surface. So remember please, here the option C will be correct, not D. Reynolds number. Now moving ahead. Question number 4. Question number 4 is, what you are telling please? Oh, C, not B. Yeah, this is B. Only, yeah. Oh, my mistake. Okay. Now moving ahead on the next question. Question number 4. In fluid flow analysis, which boundary condition can be expressed as velocity of fluid equal to velocity of wall? So which boundary condition we take care when we analyze the fluid flow and will express in terms of velocity of fluid equal to the velocity of wall? So a few minutes later, I'll discuss. Please, you first try to give your answer. So couple of minutes back I was discuss about that. So if you listen very carefully, then you can very easily to give your answer. Okay, so let me discuss. So here actually in fluid flow analysis, the boundary condition means what? Let me discuss first boundary condition, then might be you can easily give your answer. So boundary condition means what? When you will solve like fluid flow problem, you have the two method, fluid flow analysis. One you can analyze experimentally, another mathematically you can also analyze, or you can write here the numerically. When we will analyze the numerically, you need to provide some boundary condition. What is the left side? What is the right side? How much the pressure? What is your initial velocity? Such type of information you need to give your equation. Like how you will solve the numerically the fluid flow problem. So first you will try to make one geometry. Let me discuss a step here also. Like you want to analyze one pipe flow. So first of all, you will make geometry using the CAD. Then you will generate the mesh. Then you will generate mesh like that. Mesh may be the different types. Here I am only try to give your basic understanding. So first of all, initially you need to give your initial condition and boundary condition for a particular, that is your initial condition for a particular cell. So here you need to provide your velocity, pressure and everything, discharge, and this is your boundary condition. So you need to also provide the boundary condition. Basically what? In each cell, whatever your equations, Navier-Stokes equation and continuity equation, in each cell, one by one will be solved. So you need to provide boundary condition. What is the right side, left side? So basically we are talking about velocity of fluid equal to the velocity of wall. So velocity of fluid here, this is the velocity of wall equal to 0. And at your boundary, your velocity of fluid we also consider 0 because of the no slip. So this thing, the question is about that only. So the correct answer is no slip. So here you can also read notes. The boundary condition where the velocity of fluid is equal to the velocity of solid wall is known as no slip condition, and this condition is a fundamental assumption in fluid dynamics. This is a fundamental assumption, particularly when considering the flow near solid surface. It implies that the boundary between a fluid and a solid surface, the fluid particle in direct contact with the surface have zero velocity related to the surface. In other words, the fluid stick to the solid surface and does not slip past it. So hope you got it. Now moving ahead with the next question. Next question is, Friction factor in a fully developed turbulent flow. Here we are talking about turbulent flow, pipe flow, turbulent pipe flow depend on. Previously we are talking about the laminar, but here is the turbulent flow. Question number 5. Yes, please. Which problem? Yeah, oh, this is the assignment problem only, previous year assignment problem. Yeah, we have the question also. Because this is the 1 marks question. This is 1 marks question. That's why this is theoretical. The 2 marks. Yeah, yes, definitely, definitely. Okay, 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 okay. Sure, sure. Okay. So we have another 5 theoretical question, or maybe numerical question, maybe one, two. Then after all, we have the numerical questions. So for question number 5, okay, Kedar is telling option A. Okay. So here we are talking about the turbulent flow. In case of laminar flow, I was discussed previously, just a couple of minutes back. But here is the question, friction factor in turbulent flow. So please think on that. Okay, let me discuss just. So your formula is like that. 1 by root f, what I was telling previously, minus 2 log 10 epsilon by d divided by 3.7 plus 2.51 Re root f. So this is the formula for calculating the friction factor in case of turbulent. In case of laminar, your friction factor is, so it is a function of only your Reynolds number, but here is the relative roughness is also given. Relative roughness means what? Roughness divided by your D, diameter of the pipe. So it is depend on both. So your D option will be correct for this. Question number 5. Okay. So a pitot tube, question 6. A pitot tube is used for flow speed measurement, flow discharge measurement, both A and B, none of the above. Pitot tube, we are talking here, pitot tube. Yes, measuring the pressure, definitely measuring the pressure, but by using the pressure value, what we can calculate here as per the whatever the option is given. Using the pitot 2, we directly measure the pressure, but after getting the pressure, we can calculate something. Okay, flow speed. What you are telling? Actually, I didn't get. Yes, yes, yes. No, no. Just I'll tell you. If you think, if you know the Bernoulli's equation very well. Py rho z plus v square by 2z, and this is the relation between your pressure head, kinetic head, as well as your datum head, right? So using using your Bernoulli's equation, applying the Bernoulli equation, if you know the pressure, so you can calculate the velocity. So, but because here answer option is like that, so you need to choose one answer or an option here, whether A, B, C, D, or which one. So you are telling what you are telling. Actually, I didn't get. You are telling, I think, about the units of the pressure. Yes, definitely. Here we measure the speed. Okay, so now question number 7. The ratio of momentum correction factor to the energy correction factor for laminar flow in pipe. The ratio of momentum correction factor to the energy correction factor for laminar flow. Remember, please, for laminar flow. So this is the very, if you remember the direct values, then you can very easily give the answer. Otherwise, you need to. Yes, please. Okay, okay, okay. Let us wait for what is for Kedar answer. What he. Okay. So here, actually, the for laminar flow in the pipe, your kinetic energy correction factor is 2 and the momentum correction is 4 by 3. That is 1.33. So when you will divide these two things, that is 4 by 3 divided by 2, then you will get 4 by 6, and after that 0.667. So option D will be correct. Remember, please, the kinetic energy correction factor for your laminar flow is 2 and momentum correction factor 1.33, so that is 4 by 3. So similarly, you can remember for turbulent flow. Now, the question number 8, the loss of energy at the exit of submerged pipe. Which formula you will apply here? And I'll give you the numerical in this question. If your velocity is 2 meter per second and your G value is 10 meter per second square, then what will be your exit loss? So you try to solve this question also. First you need to give your answer and then after the answer of this question. This is the question X. Yes. Okay. 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 Let us see. We'll see. First, I'll wait for Kedar answer also. And you please try to calculate the numerical value of this also. Okay, Kedar is telling A option. So for exit loss, remember please, your V square by 2Z, always remember. For exit loss, your formula will be V square by 2Z. If you will calculate here your value, that is the 4 divided by 2 into 10. So 4 by 20, 1 by 5. So it means what? 0.2. It will be 0.2. Now, the next question is the loss of energy at the entry of submerged pipe. At the entry of submerged pipe. One pipe is like that. This side also submerged. This side also submerged. So this is your entry. This is your exit. So here your exit loss. Here your entry loss. So which option will be correct? And you need to calculate for question number Y. If your velocity is 3 meter per second and G value again 10 meter per second, 10 meter per second square, then what will be your ratio of both losses, entry and exit? Both loss. Both loss means here I want to know from your side H exit by H entry. That is the head loss at exit divided by H entry. So first of all, you please try to give your answer for this question, question number 9. Then you try to solve question number Y. So which option will be correct? Okay, let me just show you the answer. So for this, your option number A will be correct. That is the 0.5 times of the V square by 2Z. So option A will be correct for question number 9. So now I want to answer of this question from your side, please. The ratio of both losses, that is H exit divided by H entry. So please try to calculate. So I am audible, please just confirm. If not audible, you can write in the chat box whether I am audible or not. Okay, okay, audible. So please try to give your answer. Yes, option A is correct for question number 9. But now I want to know from your side. Question number Y I have written. Velocity is given 3 meter per second. G value is 10 meter per second square. Then what will be the ratio of H exit to H entry? If this data is given. Okay, if I give you answer, I mean if I give you the option of this question, like A option is your 0.3, B option is 0.5, C option is 2, D option is none. So which option will be correct? For question number Y. Okay, B, you are telling. Okay, okay. Okay, let me discuss. So here I am talking about the ratio. So ratio, if I talking about, there is no meaning of these values because what? In both formula V square by 2Z is involved. So no need to calculate, just ratio. What is talking about? H exit. So exit value is what? V square by 2Z divided by H entry. So H entry is 0.5 V square by 2Z. So cancel out to each other. 1 by 5, zero point 0.5. When we will remove the 0.5, it will be 10 and 5 to the 10. So your option 2 will be correct. If I was asking H entry by H exit, then 0.5 will be correct. But I was asking H exit by H entry. So here you can think about it. Your H entry, H exit, that is the loss at point exit, is V square by 2Z. So if I multiply these things by 0.5, 0.5, so this V square by 2Z into 0.5, I can write the H entry divided by 0.5. So what you will get? 2 times of H entry. 2 times. That is your H exit. The loss at the exit point is much more. That is the 2 times more of the your entry. Remember please, 2 times in case of submerged pipe we are talking about. 2 times of your entry. If I talk about in the percentage, how I will calculate? So it will be definitely 100% with respect to exit. How much loss? Because when we calculate the percentage, always need to ask with respect to what? With respect to entry or with respect to exit. So if I calculate the percentage, how much percent of your how much more in terms of percentage your exit loss? So how you will calculate your exit minus H entry with respect to what? With respect to H exit. So H exit minus H exit is equal to 2 times of, so here is entry. So entry is what? H exit divided by 2 is equal to S exit. So now you can calculate. That is your 1 minus half divided by exit will be cancelled out. So 1. So that is half. Means 0.5. If you will multiply, that will be 50%. So it means what? Your loss in, that is the percentage difference in losses with respect to what? Exit, that is 50%. So remember please. Because if I talk about with respect to entry, so definitely this will be changed. So always remember such type of things you need to remember always. Next question. The hydraulic gradient line represents the sum of pressure head and kinetic head and datum head, pressure head and datum head, pressure head, kinetic head and the datum head. So which option will be correct for question number 10? Okay, you are telling, Kedar is telling the option C, pressure head and datum head. Okay, we are talking about here the gradient line. Hydraulic gradient line. It may be the energy gradient line. Two types of gradient line, energy and hydraulic. So we are talking about hydraulic. So okay, you are telling the option C, that is the pressure head and the datum head. If I ask about the energy gradient line, then what will be the correct option? A, B, C, D, which one? If I ask about the energy gradient line. Okay, option D. Okay, I want to discuss little bit for another students. Maybe when the student will see the video, then will be more clear. So here hydraulic gradient line, let me just draw one pipe flow things. Let us insert here the piezometer. So here is the pressure is this much. Now the pressure little bit reduce. Here little bit reduced due to the friction. And if I consider the datum of, this is the datum from the center line. And from the center line your pressure is this much. Okay, so distance up to from your bottom, that is your datum to that, or whatever you will get line here one, that is your line will be followed like that, falling trend in the lengthwise direction because the friction, because the energy loss due to the friction of the pipe. So this is your what? P by rho z. So this is P by rho z plus Z. That is your pressure head and datum head. When you will add, because due to the velocity, another head will become here. What? V square by 2z. So similarly here also V square by 2z, so everywhere. So another line will be come like that. This will include your what? This is your V square by 2z, that is your kinetic energy. So this is known as energy gradient line. This is a hydraulic gradient line. Remember please. Okay, now moving ahead with the next question, question number 10. So here is some numerical value. Question number 11. So the value in pipe system cause or 3.5 meter head loss if the velocity of flow is 7 meter per second. The loss coefficient of this value of this valve, okay, the valve in a pipe system, we are valve not value, the valve in the pipe system causing a 3.5 meter head loss if the velocity of the flow is 7 meter per second. The loss coefficient of this valve is loss coefficient. So first you please try to calculate, or I'll take the 5 minute break here. So if you want to take, you can take the break of 5 minutes. So now we'll discuss about the question number 11. So question number 11 is about, okay, I have already discussed. So just uh, if you have solved, please try to write your answer in the chat box. Otherwise, I will show you the answer how I will. So let me show you. So in the question, actually head loss is given HL is 3.5 meter. Velocity is given 7 meter per second and G value is given 9.81. Okay. Now, oh, here is talking about your loss coefficient. So HL is equal to coefficient loss V square by 2G. It may be 0.5 as I have seen the previously. I've shown you. For entry loss, it will be the 0.5. So here talking about CL. So HL is 3.5 divided by V7 is square divided by 2 into 9.81. When you will calculate, you will get 1.0. So your option D will be correct for this. Now we'll move on the next question. Next question is water flow water flows in a 15 centimeter diameter pipe at a velocity of 1.8 meter per second. If the head loss along the pipe is estimated to be 10 meter, the required pumping power to overcome this head loss is what will be? Whether A, B, C, D, which one? And G value is given 9.81. So please try to calculate. For question number 12. You have 5 minutes. I'll wait 5 minutes for your answer from your side. So please try to calculate. So question number 12. Krishna, we have solved already the question number 11. So I'll just show you after question number 12. So first please you try to solve the question number 12. Question 12 is telling the water flow in a 15 centimeter diameter pipe at a velocity of 1.8 meter per second. If the head loss along the pipe is estimated to be 10 meter, the required pumping power to overcome this head loss is. So you have 4 minutes, 3, 4 minutes, 5 minutes. Yes, 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 yes. Please proceed with that. Yeah, okay. Okay, so now I want to discuss little bit. So just okay, A you are telling A option. Okay. So here actually what question? Let us suppose a pipe water is flowing something length of, maybe you just assume the length is L is given. Here your velocity is 1.8 meter, 1.8 meter per second, and head may be something, you just assume that here head may be 20. After traveling the L meter, your head loss is 10, so remaining head is how much? Remaining head is 10 meter. Here is one pump is here, so you are pumping the water through the pump. Now your head is here less, so what will happen here? Here discharge, maybe, that is the losses will be more. Whatever here is the your pressure head or entering things, that is your Q entering, that is the velocity at entering. If I tell you velocity in here, the definitely velocity will be changed. Definitely your velocity will be changed. So here the question is, velocity change means what? Your discharge will be changed, because discharge is equal to area into velocity. So at this place your discharge will be changed. Discharge should not be changed because of the continuity, because we assume like that. But just to think about, if you're due to the friction your velocity will be reduced at the out, definitely you will not get that much water. That is the speed of water previously what you have got it. So now how much the power increase here, that is the, at place of one motor we need to provide another motor of the same horsepower, so we can here increase the pressure. Let's suppose our requirement is here 100 liter, so because due to the loss we get 80 liter only. So what should increase at that point, at inlet point, how much the pressure increase, so we get the 100 meter. Loss is, definitely loss will be there, but we can increase the pressure and we can fulfill our requirement. So the question is that only. So the pressure you know already. So pressure is equal to what? From your very basic beginning, from your 12 or 11 classes, work done per unit time. So what is work? Work is nothing but your force to displacement divided by time. So if I talk about, if this formula I convert for the your fluid, so what will happen? For fluid, it will be your force into velocity, because distance by time velocity. And what is force? Force in case of your fluid, that is your mass, that is mass flow rate, into G. You know already force is equal to mg. So here we are talking about mass flow rate into, because force is equal to this, but mass flow rate, mass flow rate, mass flow rate means what? Force per unit time. If you will take the force per unit time, only d will be remain. So d means what? Your here head loss. So this is the your power. So mass flow rate means what? Your volume flow rate means discharge. Always remember please. Volume flow rate means discharge, that is meter cube per unit time. Here kg per unit time. Mass flow rate means kg per unit time. That is rho A V. This is your mass flow rate into G already in above formula, and HL, that is your loss. Now you can put your values here. Rho is 1000 into pi by 4 into D square into 1.8 into 9.81 into 10. So finally you will get 3120.40 watt, and in kilowatt 3.12 kilowatt. So this is the whole about your question. So hope you people got it. Okay. So now we'll move ahead on the next question. Okay, for Krishna, let me show you the question number 11, how actually we have done. So question 11 was about the calculate the your coefficient of, that is the loss coefficient. So you know the formula already. Yes. So you know formula already, the HL is equal to loss coefficient into V square by 2Z. Previously we have seen already for your entry case your loss coefficient was 0.5. For exit case your loss coefficient was 1. So in this question talking the question is asking about the loss coefficient. So HL is equal to loss coefficient V square by 2Z. So now you very easily calculate the loss coefficient. So HL is given in the question, that is the 7, and that is a 3.5, and velocity is given 7 meter per second. So you can easily calculate your answer. So it will come around 1.4 meter. So remember please. Oh, not meter, because here we are talking about the sea. So now we'll move on the next question, question number 13. Question 13 is about consider a pipe that branches out into three parallel pipes. Consider a pipe that branches out into three parallel pipes and then rejoin at a junction downstream. All three pipes have the same diameter. D is equal to 3 centimeter. If the friction factor is 0.025, the length of pipe 1, pipe 2 are 5 meter, 8 meter respectively, while the velocity of fluid in pipe 2 and 3 is 2 meter per second, 3 meter per second respectively. Calculate the length of pipe 3. Pipe Okay, calculate the length of pipe number 3. Neglect the minor loss. So please try to calculate based on your knowledge. So you have for this question around 5 to 6 minutes. Then I will discuss. So please try to solve and try to give your answer in the chat box. Okay, let me show you the answer for question number 13. So the graph is like that. Pipe is divided into three parts, the first, second and third. Length is given already, pipe 1, pipe 2 and pipe 3. 5 meter, 8 meter and pipe 3 you need to calculate. Velocity is given 2 and 3. And another data is given. Diameter is equal for all. That is, the area of cross section will be equal for all of pipes. Okay. Friction factor also given 0.025. So you know already, for in case of parallel pipe and the series pipe, what is the, that is the addition of head or equal, that is the equal of head. So if you will think like that, in case of your parallel pipe, the your head loss will be, if you will see here, parallel pipe, the head loss will be the similar in parallel pipe. That is, at one head loss will be similar means what? HL1 is equal to HL2. So formula you know already, FLV square by 2ZD if the friction factor is given. Obviously the friction factor is same, so it will be cancel out. So here you need to calculate your L3. For calculating L3, first of all I write a formula here. FLV square by 2ZD. So D is same for all. Length and velocity is varying. So here you have the two unknown. First velocity and second one length. So you need to two equation. So first equation you need, that is the L1 V1 square equal to, because F whatever 2Z D1, if you will do, it will be cancel out, and L2 Vt square by 2Z D2, D1 D2 will be equal. So here your L1 is equal to L2 V2 by V1 whole square. So L1 is given already. L1 is 5. L2 is how much? L2 is given your 8. V2 is how much? V2 you have the 2 meter per second. V1 you need to calculate. So 5 by 8 into equal to 4 by V1 square. So V1 is equal to your V1 square is equal to 32 divided by 5. So V1 is equal to root under 32 by 5. So from here you will calculate the V1. Now you can equate these two things. Or you can equate these two things also. Whatever, it's depend on you. So in this solution, again 1 and 3 will be equated. You can equate also, that is your 3 and 2 also, no problem. And then after Similar thing. Similarly, you will do same thing. That is your L1 V1 square divided by equal to L3 V3 square. So again, you need L3. So L1 V1 square divided by V3 square. So L1 is given already you 5. L1 how much? 5. V1 you have already calculated. So V1 if you will calculate it, that is it will come around 2.53. This will come 2.53 meter per second. So you can check the, if any mistake in the calculation, you just check. You will check, but concept is like that. So L1 is 5, V1 2.53 square, and V3 is given you 3 meter per second. 3 meter per second. So now you can easily get your L3. So your L3 value will be 3.55. Remember please. So here is nothing. You only one thing remember. In case of parallel pipe, your head loss will be equal. In case of series of pipe, your head loss will be accumulated. That is your adding. Head loss total will be H1 if this is 1, if this is 2, plus H2. How? Because how? Here is a length is, you are traveling from here to here, but in case of parallel you are traveling, just for remember point of view I am telling, you are traveling in this much only area, in this much length. So remember please, the loss will be same for all pipe, but you are traveling more in case of your series. This logic for your remember point of view, not here the conceptually not I am telling. Now moving ahead on the question number 14. Question number 14 is, two reservoirs are connected through a pipe with length 1000 meter and diameter 0.4 meter, which has a gate valve. The pipe entrance is sharp. The loss coefficient is 0.5, and the valve is half open, loss coefficient 5.5. The head difference between two reservoirs is 20 meter. Assume the friction factor for the pipe as 0.04. The acceleration due to gravity as 10 meter per second square. The discharge in the pipe accounting for all minor and major losses. Here you need to account all major and minor loss. So actually just please you try to think, and let me show you the clearly a question. Just you try to think on the question, then I will show you direct answer, because we don't have the time to I'll not give you time to solve you, because we are very limited with time. So just please try to think. Here you need to consider all major and the minor losses. 1 minute you can think on the question, then I will show you. Just 1 minute you can think how you will write the equations and all. Because if you are able to understand the concepts, if you are able to write the equation, then you can calculation point of the calculation is not big deal. Okay, now I will show you the answer. So the question is like that. Connected with the reservoir, head loss is 20 meter. Discharge length is the 1000 meter, diameter 0.04 meter. Now, so the friction factor you know already, FLV square by 2ZD. Minor losses, total loss, minor loss, major loss. So the friction loss is the major, entry loss, exit loss, and the valve was there, so that's why the valve. So K entry means the coefficient entry, coefficient exit, and the coefficients of valve. So here the coefficient of entry we have already seen 0.5. Exit we have seen 1. Valve is 5.5. Remember please. So just you need to put the value and you can very easily calculate your answer of velocity 1.93, and discharge you can calculate area into velocity. So this is very easy question. So hope you people got it what I am trying to say with about this question. So always remember the loss is maybe major, maybe minor, in because always loss will be there, major or minor. But you need to in question very clearly written whether you need to consider the minor loss or not. So here in this question we need to consider minor loss, and always remember the coefficient of loss coefficient, entry, exit, and the valve. So hope you people got it. So okay, the value of valve loss. Okay, the value of valve loss is equal to what? That is the K valve V square by 2Z. No, here 5.5 is given. The K entry you are telling about, I think we have. No, no. We not equal to. If you will see here, so this was the numerical, not like that. No, not equal. So it will be different because the your coefficient of loss will be different now. Okay, so thank you for today. We'll meet in the next class on next Monday. So thank you all. Okay, thank you, thank you. Okay, thank you. I'll upload the question answer in the file, doc file, so you will go and download and see. Okay, thank you all.